Good morning, children. Having learned the various methods of sampling and the techniques involved, we are proceeding to problem solving. Exercise 8.1, question number 16. Given an extract from Tippett's random number table. In this table, the digits 0 to 9 are repeated in equal number of times. The question is, draw a sample of 10 3-digit numbers which are even numbers. I can start from any row or any column. So the answer is not unique. The question is, I need 10 such numbers and each should have 3 digits and which should be even number. If I start from first row, 295, 3-digit number which is odd. So go on to the next box, 664. This I can consider. It is 3-digit even number. Can I go on to 399? No. 979? No. 796, 3-digit even number I can select. Even though there are 4 digits, my question is only 3 digit. So consider 3 digits of that alone. 591, it's odd. 317 odd. 562 I can select. The next idea, 416 I can select because it is 3 digit and even. 952 I can select. 154 I can select. 139 odd number. 720 I can select. Check how many we have selected. 1, 2, 3, 4, 5, 6, 7. 3 more I need to select. 535 odd number, so leave it. 130 even number. 269 odd, forget it. 267 odd. 748 is even number. One more I need to select. I can select the next one. Say 340. This is not the unique way of selecting. I have selected these numbers. You can select diagonally also. See, this way also I can select. Look at the numbers. 664, 154, 276, 600. This is odd. Go on to the next diagonal. 3, this is also odd. So diagonally also I can select 356, 812. Again next diagonal. So I can proceed diagonally or I can take column wise. First column, second column, third, fourth, like that. Or I can go row wise. So the answer is not unique. You can select in your own way but from the given table. So what are the random samples that we have chosen? 664, 796, 562. Let us take and write the numbers. 416, 952, 154, 720, 130, 748, 340. So these are the 10 3-digit even number sample that we have chosen. Again, I tell you, this answer is not unique. Anyone can select in any way, row wise, column wise, diagonally. Answers may vary. Exercise 8.1, question number 17. A wholesaler in apples claims that only 4% of the apples supplied by him are defective. A random sample of 600 apples contained 36 defective. Find the standard error concerning of good apples. As we read the problem, we have to check whether mean or standard deviation or proportion. Out of the 3, what is given here? 4% are defective tells me percentage. Percentage represents proportion. So proportion is given. How to write the standard error? Standard error of sample proportion is root of PQ by N. What is capital P? Population proportion. So the claim is 4% defective. So bad apples I will take Q and good apples I will take P. So P is population proportion. Q is also proportion, but this is of bad quality. Given 4% defective, proportion of bad apples will be 4%, which I will write 4 by 100, that is 0.04. If 4% are defective, how much will be of good quality? The remaining 100 minus 4, 96% will be good, or I will write 96 by 100, which is nothing but 0.96. Once I know capital P and Q, read the next line to identify sample size. A random sample of 600 apples. So sample of 600 tells me sample size n, small n is 600. So what all we have identified? P, Q and N. This is actually sample proportion, but for standard error we are concerned about population proportion. What is the general claim? So the general claim is 4% defective. So that tells me Q is 4%. So automatically we get what is P and naturally what is N. Substitute in the formula. Root of PQ by N, 0.96 into 0.04 divided by 600. Use calculator and find out the answer. 0.96 into 0.04 divided by 600 equals 0.4064. Find the square root of it. We get 0.008. So what is my answer? It is 0.008. Standard error of sample proportion of good apples equals to 0.008, and that is the answer. Question number 18. A sample of 1000 students whose mean weight is 119 pounds from a school in Tamil Nadu state was taken, whose average weight is 120 pounds with a standard deviation of 30 pounds. Find standard error of mean. A sample of 1000 students. Tell me sample size small n is 1000. Standard deviation of the population, the Tamil Nadu state which was taken, the standard deviation is given as 30 pounds. So the standard deviation we have written 30. My question is standard error of mean. What is the formula for standard error of mean? Sigma by root of n. So I have identified what is sigma and n as I read the question. Just substitute. What is sigma? 30 divided by root of 1000. What is root of 1000? 30 divided by, find out root of 1000. It is 31.6227. Divide 30 divided by 31.6227, that is 0.94868, approximate to 4 decimals, 0.9487, and that is the standard error of mean, what is expected in the question. Question number 19. A random sample of 60 observations was drawn from a population and its standard deviation is 2.5. Find suitable standard error that this sample is from the population with standard deviation 3. As I read the problem, here mean, proportion, nothing of that sort is given. Sample size is given. A sample of 60 tells me this is small n. So small n, the sample size is 16. Standard deviation. 2.5 is there, 3 is there. Which is for the population? Read the sentence carefully. From the population with standard deviation 3. So this I call sigma. Population standard deviation is 3. This is sample standard deviation, so it will not help me in the formula. What is the question? A suitable standard error. Which is the suitable standard error here? Mean is not given, proportion is not given. So, we will find standard error of sample standard deviation. What is the formula? Root of sigma square by 2n. Or I can say sigma by root of 2n. What is sigma? 3 by root of 2n. 2 into 16. That is 3 by root of 120. Calculate and write the answer. First you calculate root of 120 and then divide and write the answer. Root 120, 10.9544. As we divide, we get the standard error is 0.2739 and that is the answer. Question number 20. In a sample of 400 population from a village to 30 are found to be eaters of vegetarian and the rest to be eaters of non-vegetarian food. Compute the standard error assuming that both vegetarian and non-vegetarian foods are equally popular in that village. As we read out the problem, anywhere mean is given? No. Standard deviation is given? No. Then, what type of problem is it? The last word is very important. Equally popular. This question, we are dealing about vegetarian and non-vegetarian. It is given equally popular. Tells us population proportion for vegetarian 50% and for non-vegetarian 50%. If I take P as vegetarian, Q will be non-vegetarian. If one is success, the other one is failure. Somewhat like Q is 1 minus P. If this is 50%, this is also 50%, so that I can say it is equally popular. 50% tells me 50 by 100 or it is 0.5. Again 50%, so I can say 0.5. What is the sample size? In a sample of 400. So the sample size is 400. A standard error of sample proportion we have to write. What should we write for this problem? Proportion. Standard error of sample proportion. We know the formula square root of PQ by N. Having identified P, Q and N, just substitute. P value 0.5, Q value 0.5 by 400. Multiply, divide and then take square root. The answer is 0.025. So this is standard error of sample proportion.